Okay, lesson 25, geometry, congruence criteria for triangles. AAS and HL. We've already done side, 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 angle, angle, side, angle. And now we have the last two. Okay, let's start out with a little exercise. Write a proof for the following question. Once done, compare your proof with the neighbors. No, we don't have to compare with the neighbors, but let's just work together to figure this out. Okay, first we have our givens. DE equals DG and EF equals GF. Okay, those are both given. We're trying to prove that DF is the angle bisector of angle EDG. So we have those given. What else do we know? Let's mark what we have given first of all, because it's always good to see. We have DE, then these two are congruent. So now I can actually say that DF is congruent to DF, which is that middle one right here, and that is the reflexive property. Whenever you have two triangles that share a side, go ahead and mark them congruent because of the reflexive property. Now I actually have two triangles congruent to each other. Let's do DEF is congruent to triangle. Remember, you have to name them in the right order. DGF, and that is because of side, side, side. So now I can actually say those angles are congruent. Angle EDF is congruent to angle EDF GDF. Because of congruent parts of congruent triangles are congruent. Now let's go ahead and mark that. Once we know those angles are congruent, we can say that DF, segment DF, is the angle bisector. Because an angle bisector cuts one bigger angle into two equal pieces. And we know that those are two equal pieces. And the reason there is definition of angle bisector. Good job. Did you compare that with your neighbors? I'm just kidding. Today we're going to examine three possible triangle congruence criteria: the angle-angle side, the side-angle side, and the angle-angle-angle. Ultimately, only one of the three possible criteria ensures congruence. Okay, if you remember, we said that if one of your triangle congruence criteria spells a bad word, then it doesn't work. And we're going to show you why this one doesn't work too. This right here is the only one that's going to work. So let's get to work. Angle, angle, side. Given two triangles, triangle ABC and A prime, B prime, C prime. If AB equals A prime, B prime, measure of angle B equals measure of angle B prime, and the measure of angle C equals the measure of angle C prime, then the triangles are congruent. And let's talk about why. Consider a pair of triangles that meet the AAS criteria. If you knew that two angles of one triangle corresponded and were equal in measure to two angles of the other triangle, what conclusions can you draw about the third angle of each triangle? If you remember the interior that's of a triangle sums to 180 degrees. So if we know two angles of a triangle, then we can add and subtract and get the third angle. So if two angles equal to each other, then the third has to be equal to each other also. Okay, let's keep reading. Consider a pair of triangles that meet the AAS criteria. If you knew that two angles of one triangle corresponded to and were equal in measure to two angles of the other triangle, what conclusions can you draw about the third angle of each triangle? Since the first two angles are equal in measure, the third angles must also be equal in measure. Given this conclusion, which formally learned triangle congruence criteria can we use to determine if the pair of triangles are congruent? would do ASA, right? Therefore, the AAS criterion is actually an extension of the ASA, triangle congruence criterion. Note that when using the angle side criteria as a reason and a proof, you need only state the congruence and AAS, right? That's what we've been doing in the past. Pause right here real quick and let's discuss why. So the AAS criteria is actually an extension of the ASA triangle congruence criteria. Let me draw a picture over here and I'll erase it in a second. I could also go back to the last picture. Okay, we know that angle, and side. It's a extension of ASA because we just said if we know that two angles of one triangle are equal to two angles of another, then we also know that the third angle is congruent. So over here I have angle, side, angle. So it's an extension because we know that third angle is congruent because of that, that rule we learned or all the interior angles of a triangle sum to 180. So that's the reasoning there, but let me erase this and we can move on to hypotenuse leg. All right, hypotenuse leg congruence criteria. Given two right triangles, triangle ABC and A prime, B prime, C prime, with right angles B and B prime, if AB equals A prime, B prime, which is the leg, and AC equals A prime, C prime, which is the hypotenuse, then the triangles are congruent. Okay, we're going to go through a proof, but I'm going to show you a picture, just a really basic picture. Okay, we already know these are right triangles. And what we're saying is the hypotenuse of one is equal to the hypotenuse of another, and either leg is equal to either leg. Okay? This is actually angle side side, which I said isn't one that we can use. But when it's a right triangle, it's different. We're allowed to use hypotenuse leg, hypotenuse leg, hypotenuse leg, as long as it's a right triangle. Okay? But let's go through the proof. Okay, as with some of our other proofs, we do not start at the very beginning, but imagine that a congruence exists so that triangles have been brought together, such that A equals A prime and C equals C prime. The hypotenuse acts as a common side to the transformed triangles. So if you look here, I have my right angles. The legs always stem from the right angles, and the hypotenuse is always across from the right angle. Leg stems from the right angle. It's like the rays that form the right angle, and the hypotenuse is across from it. So AC is going to be our hypotenuse, and it's shared between the two angles. Similar to the proof for side, 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 we add a construction and draw B, B prime, segment B, B prime, right there. Triangle A, B, B prime is isosceles by definition, A, B, B prime, because these two sides are congruent. And we conclude that the base angles, measure of angle A, B, B prime, and A, B prime, B, and A, B, B prime, that they're equal, since angles C, B, B prime, and C, B prime, B are both complements of the equal angle measures. Remember, complements add to 90 degrees. A, B, B prime, and A, B prime, B, they are two equal in measure. So what that just said is these little angles are equal in measure, and these angles are equal in measure because they're complements of each other. Furthermore, since the measure of C, B, B prime and the measure of C, B prime, B are equal, the sides of triangle C, B, B prime, C, B, B prime, the sides of triangle C, B, B prime opposite them are equal in measure. BC equals B prime, B prime. Sorry, BC equals B prime, C prime. So BC equals B prime C prime. So let's mark that. So by side, 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 we conclude that, let's shade it, ABC is congruent to A prime B prime C prime. Okay, big triangle is congruent to a big triangle. Note that when using the hypotenuse leg triangle congruence criteria as a reason in the proof, you need only state the congruence and HL. Okay, so we have a leg and the hypotenuse, a leg and the hypotenuse, or a leg and the hypotenuse, leg, hypotenuse. Okay, criteria that do not determine two triangles are congruent, which is side, side angle and angle, angle, angle. Okay, so side, side angle. Observe the diagram below. This is the exact same diagram we discussed back in lesson 18 maybe. We were trying to construct two triangles that had two sides that were equal and an angle that was equal, but that were not equal at all. In fact, one of our students was able to draw an awesome picture using a circle and an isosceles triangle that showed that has a measure of 9 also. You know, and our base angles would be congruent, or I could construct it over here with a measure of 9. Okay, the original triangles are not congruent, but I could use the sides, two sides that are equal and an angle that is equal. So each triangle has a set of adjacent sides of measures 11 and 9, as well as the non-included angle 23, non-included. Yet the triangles are not congruent at all. Examine the composite made of both triangles. There it is. Okay, that's what we drew up here. The sides of length 9 each have been dashed to show their possible locations. The triangles that satisfy conditions of SSA cannot guarantee congruence criteria. In other words, two triangles under SSA criteria may or may not be congruent. Therefore, we cannot categorize SSA as a congruence criteria. Okay, angle, angle, angle. Of course, a correspondence exists between triangle ABC and triangle DEF. Okay, if we were sitting in the classroom, we could take some patty paper or tracing paper and trace triangle ABC and line up corresponding vertices with DEF. Okay, I drew some down here. I've got ABC and DEF. I drew two equilateral triangles. Equilateral triangles, when you have three equal sides, you have three equal angles also. Equilateral makes an equiangular triangle. So we can say that these are all completely equal angles, but the triangles are very obviously not equal. I can have equal angles and not equal sides, and I've just given you an example of an equilateral triangle to show that. Okay, based on your observations, why isn't AAA categorized as a congruence criteria? Okay, even though the angle measures may be the same, the sides can be proportionally larger. You can have similar triangles in addition to a congruent triangle. Similar triangles we're going to study here in the future, and that's where triangles have proportional sizes but not equal sizes. So let's list all the congruence criteria here, everything we've learned so far. We have angle, side angle, side, 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 side angle, side, hypotenuse leg, and angle, angle, side. The two that don't work are what we just did, angle, 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 and side, side, angle. Okay, don't try to use those, they do not work. Okay, examples. So given those criteria, let's try to prove that triangle BCD is congruent to triangle BAD. So we have, let's look. Given that BC is perpendicular to CD, so I'm going to mark that. And AB is perpendicular to AD. And measure of angle 1 is congruent to the measure of angle 2. I'm going to pause and write down the givens. Okay, what else do we know? When two triangles share a side, always mark them congruent. So I have BD is congruent to BD. And that's my reflexive property. Okay, so I have the hypotenuse. Let's see if I can get a leg that is congruent also. Okay, so what else do we know? Well, I do know that if I add angle 1 and angle, let's see, CDB, and then if I add angle 2 and angle ADB, they are both equal to 180 degrees because linear pairs are supplementary. And if I know angle 1 is equal to angle 2, I can say that the measure of angle CBD is equal to the measure of angle ADB. And that's a rule we haven't really used yet, so I'm going to star it so we can try to remember it for the future. I have two angles are equal in measure, which is angle 1 and angle 2, and they're supplementary with these two angles. So if two angles are equal in measure, then their supplements are equal in measure. Let me write that down. So if two angles are equal, their supplements are equal. Okay, if you look, if these two angles are equal and they're supplementary with these two angles, then they're equal too. You're just subtracting them from 180. All right, so measure of angle DCB, I've already marked it, and the measure of angle DCB DAB are both 90 degrees. That'd be just the definition of perpendicular angles. Lines. Okay, that they form 90-degree angles. So we know that triangle BCD is congruent to triangle BAD because of angle, angle, side. So I have angle, angle, side. Cool. All right, just so you know, there's only 2 examples on this one. So here's our last one. Okay, so given everything you see, let's prove that those triangles are congruent. I'm going to push pause and write down the given and mark up the triangle. So hold on a second. Okay, I can actually say that triangle ADB and triangle, it's ADB, so B or CBD are right triangles. And the reasoning is the definition of perpendicular lines I can also say that, BD is equal to BD because of the reflexive property. Let's mark that. Remember when two triangles share a side, go ahead and mark them congruent. Now I can actually say that triangle ABD is congruent to triangle CDB because of hypotenuse leg. Okay, hypotenuse leg can be pretty easy once you identify it as a right triangle. Alright, that's it. We learned the angle side congruence criteria and the hypotenuse leg. And then we learned two that don't work, which are the side angle and angle. Okay, those don't work, so don't use them. Excellent work today.